Hey there. You're diving in with us today to explore something that might seem simple at first glance,
Yeah,
finding 16% of 25.
right.
But trust me, there's more to this than meets the eye.
Absolutely.
We've got a whole array of strategies to unpack,
We do.
each shedding light on different facets of percentages.
What's fascinating is that each approach we'll discuss reveals a fundamental mathematical principle.
Okay.
It's like having different lenses to view the same concept,
Right.
enriching our understanding in the process.
Okay, let's unpack this. Where do we even begin with something like this?
Well, sometimes a little reframing can work wonders.
Okay.
Instead of diving straight into 16% of 25,
Yeah.
why not flip the script? Think 25% of 16.
Ooh. That's an interesting twist. I see where you're going with this.
Exactly. 25% is a familiar face.
Yeah,
A quarter, 1/4, we encounter it everywhere. And finding a quarter of something is a breeze.
you're right. It instantly makes the problem more approachable. A quarter of 16. That's 4. We already got our answer, and it feels almost effortless.
This is the elegance of the commutative property in action.
Okay.
It allows us to rearrange numbers in multiplication problems without affecting the outcome.
Right.
And this principle extends far beyond percentages,
Wow.
popping up in algebra, geometry, and even advanced calculus.
That's really insightful. It's a good reminder that understanding these fundamental principles can unlock a whole world of mathematical fluency.
It really can.
But let's say we want to explore other avenues.
Yeah.
What else could we do with our 16% and 25?
Let's try breaking down the 16% into smaller, more manageable pieces.
Okay.
Think of it like this. We can approach it as 10% plus 5% plus 1%. Each of these is relatively easy to calculate, and then we simply add them up.
Okay, so it's like we're taking the divide and conquer approach. I like
Okay.
it. So starting with 10% of 25,
Yeah.
that's just 2.5, right?
Precisely.
Okay.
And 5% of 25 would be half of that, which is 1.25.
And then that little 1% of 25 is just 0.25.
You've got it. Now for the grand finale, we add our portions. 2.5 plus 1.25 plus 0.25 equals what?
4. It's the same answer we got before, just through a different route.
Right.
This strategy seems particularly useful for folks who prefer tackling smaller calculations and then piecing them together.
Absolutely. And this idea of breaking down complex problems into smaller, solvable parts. It's a cornerstone of problem solving in countless fields, from computer programming to project management. This idea of breaking things down reminds me of another strategy that involves a bit of numerical manipulation, doubling and halving.
Oh, I'm intrigued. Tell me more about this numerical dance.
Let's revisit our original numbers. 16 and 25, we're going to double one and half the other. So double 25 gives us 50, and halving 16 gives us 8.
Okay, so we're kind of rearranging the furniture in our problem. But how does this help us get to the answer?
We've essentially created a new problem that maintains the same proportion as the original. We can continue this process of doubling and halving. Double 50 to reach 100 and half 8 to get 4.
Hold on a second. I think I see what you did there. By strategically doubling and halving, we ended up with 104. And we're looking for 16% of 25, which is equivalent to 4 out of...
25. You've hit the nail on the head. This technique cleverly transforms the problem without altering the underlying ratio, leading us to the answer, 4.
That's a really neat trick. It highlights how understanding proportions can be just as important as memorizing formulas.
Absolutely. And speaking of proportions, let's talk about the power of 100. It's like the anchor of the percentage world.
You said it. When I think percentages, I automatically think about things out of 100. It just makes everything seem clearer.
Exactly. And that's the beauty of this next strategy. Since 25 is a quarter of 100, finding 16% of 25 is the same as finding 16% of 100 and then dividing by 4.
I'm following you. So 16% of 100 is just 16.
Precisely. And since our original number 25 is a quarter of 100, we simply divide 16 by 4 and voila, we arrive at 4 once again.
This method feels particularly powerful. It's like we're scaling the problem to a level where the answer becomes obvious and then scaling back down.
That's a great way to put it. This concept of scaling is incredibly useful, not just in math, but in various fields. Think about architects creating scale models or chefs adjusting recipes for different serving sizes. It's all about understanding and applying proportions effectively.
It's amazing how these seemingly simple mathematical concepts have such wide-reaching applications. It really makes you appreciate the elegance of it all.
It truly does. But let's not forget that math is also incredibly practical. Let's ground this in a real-world scenario. Imagine you're out shopping and you spot an item for $25 that's on sale for 16% off. How much would you save?
Okay, That's a scenario we can all relate to. Now, when I'm at the store,
Yeah.
I'll admit, I don't always calculate percentages in my head.
Yeah.
I'm usually trying to estimate
Sure.
if the discount is worth it.
And that's a perfectly valid approach, but let's break down this discount using the concept of 1%.
Okay.
Remember, finding 1% is like finding the price of one tiny slice of a 100-slice pie.
So in this case, our $25 item is like the whole pie, and we need to figure out the cost of just one of those metaphorical slices.
Exactly. And to do that, we simply divide our $25 by 100, which gives us $8.25 per slice, or 1%.
All right, so each 1% of the price is worth 25 cents. And since the discount is 16%, we need 16 of those slices.
Precisely. To calculate the total discount, we multiply the price of one slice, the $1.25, by 16.
And that gives us a discount of $4. See, percentages in action helping us save money.
Exactly.
But we've explored percentages through retail therapy. Why not revisit our old friend, the fraction?
Of course. Remember, percentages are just fractions dressed up for a special occasion.
Right.
If we strip away the percent sign, 16% transforms into the fraction 16/100.
And like with any good fraction, we can simplify it, right?
Absolutely. We can divide both the numerator and denominator by 4, which gives us a much more manageable 425.
And now things are starting to look very familiar.
Indeed. Multiplying 425 by 25 is essentially the same as finding 25% of 42. We've circled back to our commutative property.
It's incredible how everything seems to connect in math.
It is.
It's like there are these underlying patterns waiting to be discovered.
You've hit the nail on the head. And speaking of patterns, let's not forget about those who calculate percentages with lightning speed in their heads. There's a good chance they're using mental math shortcuts, often leveraging common percentages as stepping stones.
You mean like how so many of us can calculate a 15% tip without even blinking?
Exactly. 15% is a common and convenient percentage to work with. So to find 16% of 25, we can start by calculating 15%, which is 3.75, and then just add that extra 1% back in.
Which we know is 0.25. Add those together, and we arrive at our trusty answer, 4.
It's like having a mental toolkit of percentage shortcuts ready to be deployed whenever you need them.
Well, there you have it. We've explored a multitude of strategies for finding 16% of 25, from flipping the script with a commutative property to embracing the power of 100, from real-world shopping sprees to the elegance of fractions and even mental math wizardry.
And through these explorations, I hope we've illuminated the beauty, flexibility, and interconnectedness of mathematical thinking. Remember, there's no single right way to approach a problem.
Right.
Embrace curiosity, experiment with different strategies, and discover what resonates